stray voltage is a voltage that is unintentionally present on the grounded surfaces of equipment and structures in livestock facilities. It can cause discomfort and health problems in animals, such as decreased milk production, lameness, and increased risk of mastitis. Installing an additional overhead ground conductor and isolating the neutral and ground connections is generally a good practice in dairy farms to mitigate stray voltage issues. Grounding the neutral and ground conductors together creates a low impedance path for fault currents. This can result in stray voltage when current flows through the ground resistance between the grounding electrodes and the milking equipment. By installing an additional overhead ground conductor and isolating the neutral and ground connections, a dedicated path is created for ground currents to flow back to the source. This helps to reduce the impedance of the grounding system and minimize stray voltage. The procedure for implementing this involves several steps. Firstly, install an overhead ground conductor between the buildings. This conductor will serve as the primary path for ground fault currents. Secondly, connect the ground conductor to the grounding electrode at each building. This ensures that each building's grounding system is effectively tied to the overhead ground conductor. Thirdly, isolate the neutral and ground connections by installing a ground bar in each panel. Fourthly, connect the ground conductor to the ground bar and disconnect the neutral conductor from the ground. This separation of neutral and ground is critical in reducing stray voltage. There are also additional considerations that should be taken into account. Firstly, use a suitable ground conductor, such as bare copper wire or aluminum conductor. The conductor should be sized appropriately to handle potential fault currents. Secondly, ensure that the grounding electrodes are properly sized and installed according to local codes. Proper grounding is essential for the effectiveness of the system. Thirdly, test the grounding system to verify its effectiveness. Regular testing can help identify any issues and ensure that the system is functioning as intended. It's also wise to consult with a qualified electrician or professional familiar with stray voltage mitigation for guidance. They can provide valuable insights and ensure that the installation meets all safety requirements. Let's delve deeper into the rationale behind these steps. The issue of stray voltage arises from the fact that in typical electrical systems, the neutral and ground are bonded together at the main service panel. This creates a situation where any current flowing back to the source through the neutral conductor can also take a path through the ground, especially if there are any imperfections in the neutral conductor's path. The ground, being connected to various metallic structures and equipment, can then develop a voltage potential relative to the earth, which animals can perceive as stray voltage. This is particularly problematic in dairy farms, where animals are in constant contact with grounded surfaces. By isolating the neutral and ground connections at each supple and providing a dedicated overhead ground conductor, the return path for fault currents is rerouted. The overhead ground conductor provides a low impedance path directly back to the source, minimizing the current flow through the earth and reducing the voltage potential on grounded surfaces. The selection of the ground conductor is crucial. Bare copper wire is a common choice due to its excellent conductivity and corrosion resistance. Aluminum conductor is another option, but it must be properly sized to account for its low conductivity compared to copper. The size of the conductor is determined by the potential fault currents that it may need to carry. Local electrical codes, like the National Electrical Code or NEC, provide guidelines for sizing ground conductors based on the size of the service conductors. The installation of grounding electrodes is also a critical aspect of the system. Grounding electrodes, such as ground rods or ground plates, provide a connection to the earth, allowing fault currents to dissipate safely. The NEC specifies the types and sizes of grounding electrodes that are permitted, as well as the methods for installing them. Proper installation involves driving ground rods deep enough into the earth to reach a point where the soil has a stable moisture content. The number and spacing of ground rods are also important factors in achieving a low grounding resistance. Testing the grounding system is essential to ensure that it is functioning effectively. Grounding resistance testers can be used to measure the resistance between the grounding electrode and the earth. A low grounding resistance is desirable, as it indicates that fault currents can flow easily to ground. The NEC specifies maximum grounding resistance values, and if the measured resistance exceeds these values, additional grounding electrodes may be required. Regular testing of the grounding system is recommended, especially in environments where soil conditions can change over time. This can help identify any degradation in the grounding system and allow for corrective action to be taken. When installing the ground bar in each panel, it is important to ensure that the neutral conductor is completely isolated from the ground. This means disconnecting the neutral conductor from the panel enclosure and any other grounded surfaces. The ground conductor should then be connected to the ground bar, providing a dedicated path for ground fault currents. It is also important to label the ground bar clearly to indicate that it is the sole point of connection for ground conductors. This can help prevent accidental connections that could compromise the isolation of the neutral and ground. Consulting with a qualified electrician or professional familiar with stray voltage mitigation is highly recommended. These professionals have the knowledge and experience to assess the specific needs of the dairy farm and design a grounding system that is tailored to those needs. They can also provide guidance on the selection of appropriate equipment and materials, as well as ensure that the installation meets all applicable codes and standards. Stray voltage mitigation is an ongoing process, and it is important to monitor the system regularly to ensure that it is functioning effectively. This can involve periodic testing of the grounding system, as well as visual inspections of the wiring and equipment. Any issues that are identified should be addressed promptly to prevent stray voltage from becoming a problem. Remember that stray voltage can have a significant impact on animal health and productivity, so it is important to take proactive steps to mitigate it. By following the procedures outlined above and consulting with qualified professionals, dairy farmers can create a safer and more comfortable environment for their animals. Furthermore, consider the specific layout and electrical configuration of the dairy farm. Factors such as the distance between buildings, the type of equipment used, and the soil conditions can all influence the effectiveness of the grounding system. A thorough assessment of these factors is essential for designing a grounding system that is tailored to the specific needs of the farm. It's also important to consider the potential for future expansion or changes in the electrical system. The grounding system should be designed to accommodate these changes, ensuring that it remains effective even as the farm evolves. Regular maintenance of the electrical system is also crucial for preventing stray voltage. This includes inspecting wiring for damage, tightening connections, and replacing any worn or damaged components. A well-maintained electrical system is less likely to develop faults that can contribute to stray voltage. In addition to the technical aspects of stray voltage mitigation, it's also important to educate farm personnel about the issue. Employees should be trained to recognize the signs of stray voltage and to report any concerns to management. They should also be instructed on how to safely interact with electrical equipment and to avoid contact with grounded surfaces that may be energized. By creating a culture of safety and awareness, dairy farmers can further reduce the risk of stray voltage and its impact on animal health and productivity. Finally, remember that stray voltage mitigation is not a one-size-fits-all solution. The best approach will vary depending on the specific circumstances of each dairy farm. Consulting with qualified professionals and conducting a thorough assessment of the farm's electrical system are essential for developing an effective and sustainable stray voltage mitigation plan. Keep in mind that the goal is to create a grounding system that provides a low impedance path for fault currents, minimizes the current flow through the earth, and reduces the voltage potential on grounded surfaces. By achieving these goals, dairy farmers can create a safer and more comfortable environment for their animals, improving their health and productivity. For example, if the soil conditions are particularly poor, it may be necessary to install additional grounding electrodes or to use chemical soil treatments to improve the conductivity of the soil. If the distance between buildings is significant, it may be necessary to use larger ground conductors to minimize voltage drop. And if the farm uses sensitive electronic equipment, it may be necessary to install surge protection devices to protect the equipment from damage due to voltage spikes. The NEC provides detailed guidelines for grounding and bonding electrical systems, and it is important to follow these guidelines closely when designing and installing a grounding system for a dairy farm. The NEC also includes specific requirements for agricultural buildings, which address the unique challenges of these environments. In addition to the NEC, there may be local codes and regulations that apply to electrical installations in dairy farms. It is important to be aware of these codes and regulations and to ensure that the grounding system meets all applicable requirements. Remember that electrical safety is paramount, and it is always best to err on the side of caution when designing and installing a grounding system. Consulting with qualified professionals and following all applicable codes and regulations can help ensure that the system is safe and effective. Lastly, after the installation of the overhead ground conductor and the isolation of the neutral and ground connections, it is crucial to perform a thorough testing and verification process. This involves measuring the voltage potential on various grounded surfaces throughout the dairy farm to ensure the stray voltage levels have been reduced to acceptable levels. The specific voltage levels that are considered acceptable will vary depending on the type of animals being housed and the sensitivity of the equipment being used. However, in general, the goal is to reduce stray voltage levels to below 1 volt or less on all grounded surfaces. If stray voltage levels are still above acceptable levels after the initial installation, it may be necessary to make further adjustments to the grounding system. This could involve adding additional grounding electrodes, improving the conductivity of the soil, or modifying the wiring of the electrical system. It is important to continue monitoring stray voltage levels on a regular basis to ensure that the system remains effective over time. Changes in soil conditions, equipment usage, or electrical wiring can all affect stray voltage levels, so it is important to be vigilant in monitoring the system. Ultimately, the goal of stray voltage mitigation is to create a safe and healthy environment for the animals, as well as to protect the electrical equipment from damage. By following the procedures outlined above and consulting with qualified professionals, dairy farmers can achieve these goals and improve the overall operation of their farms. Remember, the investment in a well-designed and properly installed grounding system is an investment in the long-term health and productivity of the dairy farm.